everyone, myself Sai Prasad, a lecturer in AhleBait High School in the Junior College. Welcome to a series of the lectures of 9th class maths. We have discussed different chapters in our 9th class, started with our real numbers and recent triangles also. Today we are going to start a new chapter, that is quadrilaterals. What do you know about quadrilaterals? Just tell me. A quadrilateral is a simple polygon with at least, with 4 sides. Yes. What is the famous quadrilateral you know? That is a square and a rectangle. Yes or no? Fine. Those are the basic quadrilateral which you would have seen from your childhood. Today we are going to have a basic introduction about what are the different quadrilaterals we have and what are the different properties, physical properties they have and how do they vary from each other. Clear? Just tell me, for any quadrilateral we will definitely have 4 sides, 4 angles and 2 diagonals, right? 4 sides, 4 angles and 2 diagonals. Yes, based on these 10 parameters we are going to define whether any angle is equal, which means either all angles are equal or opposite angles are equal, or they are 90, which means opposite are 90, or only all angles are 90, right? And the next we can have a discussion like whether both the diagonals are equal, whether both the diagonals bisect each other or diagonals are perpendicular to each other, okay? And not only that, opposite sides are equal or parallel, okay? These are different parameters which we are going to check, okay? See here, we are going to discuss these 5 quadrilaterals. What are they? Trapezium, parallelogram, rhombus, rectangle and square. How does a trapezium look? You people know very well, with opposite sides parallel to each other. Next, parallelogram, it is a simple parallelogram in which opposite sides are equal and opposite angles are also equal. Yes. Next, a rhombus. How does a rhombus look? It has almost same properties of square, but a little difference. What is that? We will see. Next, a rectangle, opposite sides are equal and all angles are 90. Then the final and the most favorite is square. All sides are equal, all angles are equal. Yes. Then what are the different properties? See here, only one pair of parallel lines are there, okay? Only one pair means at least, one pair of parallel lines should be there. Yes, there is one pair. Obviously there is a parallel, or almost everything has at least one pair of lines. So everyone is okay. Fine. Next, 2 pairs are parallel. Now check here, we have only one pair here. Here 2 pairs are parallel, here also 2 pairs are parallel, this is one pair and this is one more pair. Here also 2 pairs are parallel, obviously in square 2 pairs are parallel. Clear? Next, opposite sides are equal. Are these 2 sides equal? Obviously no. Trapezium may not be of the same side, they can be of different sides, but trapezium is simply a quadrilateral with 2 parallel sides with a different shape, whatever shape it may have. Clear? Next, see here, which means opposite sides are equal in this and this. Done? Nice. Next, opposite angles are equal. Here also the angles are not at all equal. Here opposite angles are equal, here, here and here. Done. Next, diagonals bisect each other. Tell me, here do the diagonals bisect each other? First of all, there is no chance of getting a fixed number. How do they bisect? Here, tell me, do they bisect each other? Right? Yes, in a parallelogram they bisect each other. Oh, sorry. They bisect each, sorry. Here it is. They bisect each other. Clear? Then what about in rhombus? Here also they bisect each other. In rectangle, rectangle is also a form of parallelogram, therefore it also bisects. In this also the diagonals bisect each other. Even in square the diagonals bisect each other. Fine. Next, all sides are equal. No. Here no, here no. In rhombus, yes, all sides are equal. In rectangle, no. In square also all sides are equal. Next, diagonals perpendicular to each other, right? Just check here. Here no chance of perpendicular. Here also no chance. First of all, it is too slant. In rhombus, yes, they are perpendicular to each other. In rectangle, no. And in a square, yes, they are perpendicular to each other. Okay, clear? Now just tell me, what is the difference between rhombus and a square? Almost they have same properties. The only difference is here the sides will not have 90 degrees. That is the only difference between rhombus and square. Clear? Did you get a basic idea? Shall we do few problems? Let us do. Look at the question here. He gave a diagonal of a parallelogram, divides it into two congruent triangles. Remember, from here we are going to solve more proofs. Okay, most of the chapter is only proofs, so don't get scared. Remember the basic rules. See here, let us consider a parallelogram ABCD. He is telling that a diagonal AC. Okay, now what is given? Given ABCD is a parallelogram where AC is diagonal. Clear? Now we have to prove that it divides into two congruent triangle HMs. That is, we have to prove triangle ABC is congruent to triangle ADC. Okay. Now let us consider those both triangles now. If you observe, AB is equal to CD. Why? Since ABCD is a parallelogram, since ABCD is a parallelogram, opposite sides are equal. Similarly, AD is equal to BC, again since ABCD is a parallelogram, right? And one more thing, AC is common. Yes? Yes or no? Therefore, triangle ABC is congruent to triangle ADC by using SSS congruency. How? Tell me, these three sides are equal. Obviously, these two triangles are congruent to each other. Remember, a diagonal divides the parallelogram into two congruent triangles. Clear? See the next question. In this figure, ABCD is a parallelogram and ABEF is a rectangle. Okay. Then show that he is asking us to prove AFD is equal to triangle BEC. Okay. Now see here, given ABCD is parallelogram, ABEF is rectangle. Okay. Now proof. If you observe, AF is equal to BC, right? AF equal to BC. Clear? Next, why AF equal to BC? Because it is a rectangle side, because AF equal to BC, sorry, AF equal to BE, don't get confused. AF equal to BE because ABEF is a rectangle. Obviously, opposite sides are equal. Clear? Next, AD equal to BC. Why? Because ABCD is a parallelogram. Clear? And one more thing, this is a right angle triangle. Why? Because the rectangle itself is a right angle, therefore this is also a right angle. Angle AFD is equal to angle BEC, that is equal to 90 degrees. Why? Because ABEF is a rectangle. So rectangle will have all four 90 degrees. Now just tell me, one side AF, one side BE is equal, one hypotenuse AD and one hypotenuse BC is equal, and one more is 90 degrees. Therefore, by RHS, can I tell that these both triangles are congruent? That is it. Therefore, triangle AFD is congruent to triangle BEC by RHS congruency. Clear? Did you understand? Without congruence rules, we can't even prove basic questions of this chapter. Shall we do next problem? Let's do. Look at the next question here. Here they gave, in a quadrilateral ABCD, the bisectors of angle C and angle D. Let us take some quadrilateral. Let us take some random quadrilateral like this, A, B, C and D. Okay. He is telling that the bisectors of angle C and angle D, okay, they are intersecting at O. Fine. That is, this is equal to this and this is equal to this, right. Now let us prove. What is given? ABCD is a quadrilateral. Then what do you know? Sum of angles in a quadrilateral is always equal to 360. Yes, we know that. Let us divide everything by 2, or else let us send this C plus D that side, because these are the two angles which are they are telling that they are bisected. That is, angle A plus angle B is equal to 360 minus angle C plus angle D. Okay. Now let us divide it by 2. Let us divide it by 2 on both sides. Then it will become half of angle A, half of angle B. Half of 360 is how much? Half of 360 is 180 minus half of angle C plus angle D. Clear? Let us put it like that. Let us not touch it. Okay. Next, consider triangle the COD. Okay. Consider triangle COD. Okay. If you observe, what are the sum of angles in a triangle? 180, right? Yes. Now say here, angle ODC plus angle DCO plus angle COD is equal to 180. Yes, right. Now just check here, can I write COD, this angle COD is equal to 180 minus of angle ODC plus angle DCO. Yes, I am sending these two on right hand side. Now if you observe, 180 minus, what is ODC? ODC is obviously half of, what is it? Half of angle D. What about this? DCO, this is also half of angle C. Clear? Now can I write it as 180 minus half of angle D plus angle C? Yes. Now see here, from 1 and 2, if you observe, this right hand side is both same, 180 minus half of C plus D, half of C plus D. So from 1 and 2 we can write that half of angle A plus angle B is equal to angle COD. Therefore, from 1 and 2 I can tell as angle COD is equal to half of angle A plus angle B. Clear? This is one of the important question. Clear? Shall we move on to the next proof? Let us do. Look at this theorem here. He is asking, show that the angle bisectors of a parallelogram form a rectangle. Okay. Let us draw a parallelogram. Okay. A, B, C, D. Okay. The angle bisector set sums. This is one angle bisector, this is one more angle bisector, right. Let us extend it neatly. This is one angle and this is one more angle bisector. Okay. Let us assume them as PQRS. Okay. PQRS. Now we have to prove that this is a rectangle. Okay. Now see here. Let us start proof. What is given? Angle, these are angle bisectors, that is this is equal to this and these both are equal. Clear? Now consider a parallelogram in which you have to remember one thing, the adjacent angles of a parallelogram is always complementary. Okay, that is in ABCD angle DAB plus angle ABC is equal to 180. Clear? DAB plus ABC is equal to 180. Fine. Now let us take half of it. Angle half of DAB plus half of ABC is equal to 90. Clear? Did you understand? Angle DAB, okay, and angle ABC, half of that is, let us assume, this part. Now if you consider triangle ARB, okay, angle RAB plus angle ABR plus angle ARB is equal to 180. Clear? From this, what is RAB? RAB is nothing but half of angle DAB, right? Similarly, angle ABR is nothing but half of angle ABC plus ARB is equal to 180. Okay. Then what is this? From 1 I can write this value as 90. Yes. Therefore, angle ARB is equal to 90. Clear? That is, this angle is 90. Yes. Similarly, we can prove from this side, we can prove these three angles are also 90. Similarly, we can prove angle PSR plus angle PQR, that is equal to angle PSR equal to 90. Therefore, PQRS is a rectangle. Clear? The only thing you have to prove that the sum of these two is equal to obviously 90, because half of it, that is equal to this 90. Clear? Did you understand? Look at these questions here. He gave 4 angles of quadrilateral and the ratio 1:2:3:4. Okay. What is the sum of angles in a quadrilateral? 360, right? So, let us write angles B 1x, 2x, 3x, 4x. Okay. Then sum of angles is 360, that is x plus 2x plus 3x plus 4x is equal to 360. Okay. How much is it? 3, 6 and 10x is 360. From that I can write x is equal to 36. Okay. Yes. Let us substitute this in each angle. X is 36. What about 2x? 2 into 36, which is 72 degrees. Next 3x, 3 into 36, how much is it? 108. Similarly 4x, which is 144 degrees. Clear? Therefore, the angles are 36, 72, 108 and 144. Okay. Look at the next question here. The opposite angles of a parallelogram are given. What do we know about the opposite angles of parallelogram? They are equal. So, 3x minus 2 is equal to x plus 48. Okay. Now, let us bring all variables to one side, constants to another side. X this side, 2 that side. 3x minus x is equal to 48 plus 2, that is 2x is equal to 50, x is equal to 50 by 2, that is x is equal to 25 degrees. Clear? Let us substitute in that. 3 into 25 minus 2, that is 75 minus 2 is 73, x plus 48, that is 25 plus 48. How much is it? 73 degrees. Are these both equal? Yes, right. And what about the remaining two angles of a parallelogram? They are, let us say, A, B, C, D. Let us say these are A and C. Okay. Then what about B and D? Adjacent angles of a parallelogram are complementary, that is angle A plus angle B is equal to 180. Angle A is 73 plus angle B is 180. Therefore, angle B is 180 minus 73, which is angle B equal to how much? 180 minus 73 is 107 degrees. Not only that, angle D is also 107 degrees. Clear? These are all the minimum questions of quadrilaterals. What all we learned today? We started with the basic properties of quadrilaterals, then we did few theorems and problems. Clear? Fine. This is for today. Let us meet in the next session with the more problems of quadrilaterals. Thank you.